Alrighty, so today we're going to go ahead and start talking about tangent lines and some other properties that they have. So line LP is tangent to circle O at point P. So tangent lines today will talk about things that hit a circle at one point. Theorem time. Dun, dun, dun. If a line is tangent to a circle, then the line is perpendicular to the radius drawn to the point of tangency. So if it is perpendicular at point P, if it is tangent at point P, then I can draw a perpendicular line from point P to the center O, and that creates a right angle, which allows us to do stuff with degrees. So I forgot to get this labeled. I need to do that again. So ML and MN, so this is M, this is L, and this is N, are tangent to circle O. Find the value of X. Well, what happens at a tangent line? It's equal to 90 degrees. So that means this angle is 90. And that angle is 90 because they're both tangent. It tells me to find the value of X, and it gives me this little hint. The internal angle of a quadrilateral add to 360. So 360 minus 90 minus 90 minus 117. Which gives me the answer of 63. So X is 63 degrees. It's telling me that AD is tangent to circle O. Find the value of X. This is supposed to say AD. I don't know why there's an L there. Ignore that. So again, and this time I have a triangle, so it's 180 minus 90 minus 38. Which says that X is 52. Alright, Pythagorean theorem only works with right triangles. A squared plus B squared equals C squared. A and B could be interchangeable. I could say that this side is actually B and this side is A. It doesn't matter as long as I am aware that C is the it's the hypotenuse and it's across from the right angle. So keeping that in mind. Can you see that whole thing? Yes, okay. In the diagram, PQ is tangent to circle O. Find the value of X. Well, it's telling me it's tangent, so when it's tangent, it creates a right angle. So that means I have a leg at X. So I have X squared, plus another leg of 10, so I have 10 squared, is equal to X plus 7 quantity squared. Because the length of my hypotenuse is not just X, and it's not just 7, they're being added together. So I have X squared plus 100 is equal to, well, the squared part means I'm essentially multiplying it by itself again. So I have to FOIL. So I have X times X, which is X squared. X times 7, which gives me 7X. 7 times X, which gives me 7X again. And then 7 times 7, which gives me 49. So I have X squared plus 100 is equal to X squared plus 14X plus 49. Subtract X squared from both sides. I get 100 is equal to 14X plus 49. Subtract 49. Get 51. X is then equal to 3.64 centimeters. Okay, this one's a little bit different. I am aware that the picture is not perfectly to scale, because typically something with a 2.4 inch radius would be much smaller than what it looks in the picture compared to the 9.3 inches. So we know at some point in time we're going to need to do something with our tangent lines. What I'm going to do is I'm going to subtract this piece here, my 2.4 inches from my 9.3. And when I do that, it ends up giving me 6.9. And what I'm doing is I'm essentially moving, you can't see what I'm doing on my computer, I'm moving this circle down here. So now I'm only going to actually work with 6.9 inches. And I know, again, it doesn't look like it in the picture, but the idea is to try and make something parallel to this line. Again, it's not perfectly to scale. So it would look more like this if I actually drew it correctly. Which again, is not to scale. So what happens here is I can have that right angle created. The 26.5 inches is now here, and I'm looking for that hypotenuse piece. So using my trig, or my Pythagorean theorem, I have 26.5 squared plus 6.9 squared is equal to x squared. And I can go ahead and just plug that all into my calculator at once. So 26.5 squared plus 6.9 squared gives me 749.86. Now I want to undo something squared. To undo a squared term, I square root. So I'm going to square root that answer. So my x is 27.38 inches. So that one, I had to play around with my picture in order to be able to find what I needed to do. So keeping this one in mind, go ahead and try this one. So pause the video, come back and check your answer. Alright, I hope you guys got 35.51 inches. Alright, theorem part 2. If a line in a plane of a circle is perpendicular to its radius, add an endpoint on the circle, then the line is tangent. So this sounds very similar to my first theorem. So my first theorem is saying that if it's tangent, it has to be perpendicular. This one is saying the opposite, and that if it's perpendicular, then it is tangent. So it's showing that the theorem can work both ways. So we're going to use that to determine whether or not AB is tangent to this circle. So if it was tangent, we would assume that there would be a right angle there. When we deal with right angles, we can use my Pythagorean theorem. So I would say, is 7 squared plus 24 squared equal to 25 squared? Okay, so I get 49 plus, I don't know, 24 squared off the top of my head, 576. Is that equal to 625? Well, Is 49 plus 576 equal to 625? Yeah, I get 625. So 625 is equal to 625. So yes, it is tangent. So what I'm going to say down here, I'm going to type it because I can type faster on here than I can write. And you can be able to read it easier. You can't see there. You can see there. Is it tangent? Yes. Line AB is tangent to circle C at point B, based on the I actually got it right. So yes, AB is tangent to circle C at point B based on the Pythagorean theorem. So I want you to pause and try these two. Determine if these two are tangent or not. Now this one doesn't say explain. So I just need to know tangent or not. So pause video and do that one. So we should get that the first one is not tangent and the second one is tangent. All right. Theorem part 3. Two segments tangent to a circle from a point outside the circle are congruent. So that means that TS and US are congruent. Okay. Circle O is inscribed in the triangle ABC. Find the perimeter of triangle ABC. So I'm going to scoot this up a little bit so we can see the whole problem. So in the last theorem, we talked about if this piece is 15, then this piece has to be 15. If this piece is 8, then this piece has to be 8. If this piece is 10, then this piece has to be 10. So I have 30, because 15, 15, plus 16, plus 20, which gives me 66 centimeters. All right, using that same idea, if it's inscribed again, if it has a perimeter of 88 centimeters, find QY. All right, well, that's some unknown. So say it's my favorite letter W, because W is not used in my problem yet. I know that this has to be 15 and this has to be 17. So I have 30 plus 34 plus 2W must be 88. So 2W is equal to 88 minus 64. 224. So then W has to be 12 centimeters. So that missing side has to be 12. All right, have fun on your homework.